Hello and welcome to this video. Today we will solve the leetcode problem to remove linked list elements. In this problem we have been given the head of a linked list and an integer val, and we've been asked to remove all the nodes of this linked list which have the value equal to the input val, and we need to return the new head. In the example provided, we have the head pointing to the linked list and we have val equal to 6, and we are required to remove all the nodes where the value matches 6. Each element of the linked list is represented by a list node. Each list node contains an integer val and the reference to the next node in the linked list, which is next. So let's understand what removing a linked list node involves. So for example, I have my linked list with the head pointing to the first element 1. 1 has a reference to the next element 2, and 2 has a reference to the next element 3. Let's say I want to delete the element 2. What I need to do in this case is I would need to make the reference next inside of the head node point to the node 3 instead of the node 2. So that would mean head.next equal to head.next.next. Since head points to node 1, head.next points to node 2 and head.next.next points to node 3. By doing this, we're saying change the node 1 such that make its reference point to node 3 instead of node 2. In Java, we have garbage collection, which takes care of deallocating any unused memory. So in this case, the node 2 will be eligible for garbage collection, and that effectively deletes the node. Now let's look at how we can delete all the nodes from a linked list whose value matches val. Now to delete all the elements from a linked list matching a value, we need to traverse the linked list from the start till the end. We just saw that if we want to delete a node, we need to make its previous node point to its next node so that it skips over the node we want to delete. But what if our linked list is such that the node we want to delete is at the start of the linked list? To overcome this problem, we can delete all the nodes at the start of the linked list which match our given value. We can then traverse the linked list and delete the remaining matching nodes from it. To delete the nodes from the start which match, we will simply check if the head's value matches val, and if it does, all we need to do is make head point to the next node by saying head equal to head.next. We will do this in a while loop till all the elements at the start of the node matching the val have been removed. After removing the first matching node, we have moved our head to the next node. We do the check again and see that it matches as well. So we move head to the next node, which is 1. Now head points to the first node 1. And it doesn't match our value. Since we need to return the head of this linked list, we cannot move it, else we will lose track of the first node. So we will define a temporary reference called current. Current will initially point to the same node pointed by head. We will now iterate through this linked list using this temporary current node and check the value of the next node. If the next node's value matches our val, we'll make current.next point to the node after the next node. Doing this, the node 1 will now point to node 2 instead of the node with the value 6. We will again check the value of the next node from the current node to see if it matches our val. In this case, it doesn't. So we will move current node to the next node by doing current equal to current.next. From the new current node, we will again check the value of the next node to see if it matches our input val 6. In this case, it doesn't, so we will simply move current to the next node. Checking the value of the next node from the current node, we can see that the next node matches our input val 6, which means we need to delete this node. We will execute current.next equal to current.next.next, which means the node 3 will now point to the null, effectively deleting the node matching the value 6. At this point, we have finished iterating through the entire list and we can return the head of the list. Now let's implement our solution using an iterative approach and then a recursive approach. We'll start iterating the linked list and remove all the nodes which match the val from the beginning of the linked list. To handle the scenario where all the elements of the linked list have the same value as the val, we need to make sure that the head is not null after we have removed all the matching nodes so far. We will create a temporary reference called current and initialize it to head and use it to iterate through the rest of the linked list. We will iterate through the linked list till the next element is not null. and we will check if the next element's value matches well. If it matches, then we will delete the next node from the linked list. Else we will move the temporary reference current to point to the next node. We will return the head of this linked list. I have added a few different test cases. In the first test case, the number we want to delete occurs at the start, middle and end of the linked list. Now let's implement our recursive version of this algorithm. In the recursive approach, we will call our method recursively. We'll first check if the head is null and return null if it is. We will try and remove all the elements from the beginning of the linked list which match our input well, and if all the elements had matched, that means we would be left with a null and we will return it. I'll use this example here to explain the recursive approach. The above while loop will make sure that the matching value 6 is deleted from the start of the linked list. Now we know for sure that the first element of the linked list will not be matching the input val 6, so we will have to check the remaining part of the linked list for any matching values. We will call our method recursively and pass it the remaining part of the linked list by calling head.next as the first parameter and assign the return of this call to the head.next itself. The first time we call our method recursively with the sublist, the first element of the sublist is 2, and since it doesn't match our val, the while loop will not execute and it will then recursively call our method with the sublist starting at number 6. The while loop will now delete this head element of the sublist because it matches the input well. We will again recursively call the remaining part of the sublist recursively, and this way we will be able to remove all the matching values recursively. And finally, we will return the head of the linked list. These were the two algorithms where we were able to delete nodes from a linked list matching a given value in a single pass. I hope you found this video useful. Please remember to subscribe and like and share this video. Thank you.